Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at reading and writing binary files in C++. And I want to thank James for pointing out a problem with the earlier version of this video. And also, as I mentioned in the last tutorial, I discovered yet another problem with it that could have tripped you up, which we went over in the last video. So now I've got this struct which I've removed padding from, and we're going to write that to a binary file and read it back again. So let's go to this project here, make sure I'm working on the right project. So I'll get rid of this size of, now that we know that our struct is definitely not padded, and I'm going to include fstream here, and we're going to be using the standard namespace. First, I need a name for my file, and I like to declare the name rather than just use it when we open the file, because then we can, if we declare it as a variable, we can use it later and we can use it in error messages. So let's say string file name. Well, yeah, I'll just call it file name equals, and I'll make up a name. Let's say test.bin, bin because it's a binary file, but you can call it absolutely whatever you want. The extension doesn't have to be bin, and you can specify a complete file path here if you need to, or a relative file path, and the format of that just depends on if you're using Windows or Unix. So don't forget, you won't be able to view this in a text editor, or if you can view it, it's just going to look like a mad string of bytes, because that's exactly what it is. It's not going to be text, it's going to be raw data. So we can open this now, and to open it I need a object of the type offstream. So I'll declare that, and we'll call this, let's call it output file. And now we've got our output file object, we can open it. So I can say output file.open, pass in the file name. And the thing that I forgot in the first version of this tutorial, apart from the struct padding stuff, is that we need to say ios : binary here. That's really important, because the default is like a text file format, and what that means is that C++ will translate new line characters as it thinks, as it feels appropriate in your file, and we don't want that, because a binary file doesn't have new line characters in it. Or if it does, they're not meant to be interpreted as new line characters, they're just more raw data. So we need to have that in here to prevent C++ from messing up our file in this way. Now we can check if the file's open or not. So after we open a file, we've got to close it, and we've got to check if it's open as well. Let's close it first. Let's say output file.close. And we also need to check if it's open. Let's say if output file.is open, because it might fail to open for some reason, like you don't have permission to create files in your directory system, or there's not enough space or whatever. So we can put our code in here, and in fact we can put the close in here as well, because we only want to try to close it if it really is open, and the rest of our file for writing, our code for writing to it, is going to go here. We might as well put an else in there, and we can say cout could not create file, and let's add on the file name there. So let's write plus file name, because there's nothing worse than an error message that about a file and it doesn't even tell you what file it's talking about. That's very confusing. If you want, you can use fstream instead here. The only significant difference for our purposes here between fstream and offstream is that this is an output file stream. If you use fstream, you need to specify here, you need to use the bitwise OR operator, which we'll be looking at a bit later on, and say ios out as well here. So this OR operator is combining these two sort of flags into one single number, which is supplied to the open function. But if you use offstream instead of fstream, then this is the default anyway, so you don't need it. Now we can write to our file by saying output file.write. And what are we actually going to write? Well, I want to write my struct here. So let's just comment this out for a second, because I need to have a struct with some data in it. I need an instance of this struct. So up here, I'm going to say person someone, and the quickest way to initialize a struct is to do the following. You can initialize the members separately, like we could say person someone and then someone dot name equals such and such, someone dot age equals such and such, but it's quicker to put equals, curly brackets, and then just list the values. There are other ways to initialize a struct, and I'm pretty sure we're going to be looking at those later on in the course, because we're definitely going to be looking at initialization in C++11. But if we set it equal to the contents of curly brackets, we can just put some data in here. We can make the name Frodo, the age, let's say 220, and the weight. Let's actually maybe give him a height instead, and give him a height of 0.8 meters. This is very short, very old person. Now to write this, I need to supply the object containing the data I want to write. So if you just have a pointer, like a char pointer that's pointing to some data, you can just put that variable right in here. But since we've got a struct here, we're going to have to convert it to a char pointer. So since we've got a struct, where are we? Here, I should say. So first of all, this is our actual data, and we need the address of it, because it help if I put it in the right place in write. So there's our data. We want to write this, but we need to supply the address of it to write, not the actual object. So I need to take the address of this, and what we've got now is now we've done that, we've got the address of this struct type variable. What we've got is a person pointer in effect, and that points to this data. So that's no good, because write is expecting a char pointer. Now, the old way of casting some other type of pointer to a char pointer is to write this char pointer. So that works, and we'll look at another way in just a second. But we also need to supply how much data we want to write in bytes. So I'm going to use here size of, and we could write size of someone or size of person equivalent here. So that would actually work, but there is a kind of newer way of casting between pointers, because we've got various casts, which we'll look at later, which enable you to do specific types of casting that are therefore maybe less error prone and maybe easier to read if you're familiar with them. I must admit I'm a bit addicted to this way of doing it, because this is how I did it for years, but it's probably better if we do reinterpret _cast, and then in sort of angle brackets here we need to specify the type to cast to, which is char pointer, and then in round brackets we put the pointer that we want to cast, which is just the address of our data. So this is considered a better way of doing this, although I must admit I do use the old way too much, really. Okay, so this is going to create our file. We can check if this works, but we're not going to be sure that we've really written the data just yet. But let's build it and run it. And now if I right-click Eclipse and go to refresh, if I right-click the project, we see here our test.bin. And you could go to your Finder or Explorer or whatever you use to look at the file system and check that this has something other than a 0 size as well. But now let's put in some code that reads the file. Normally you'd have the reading and writing done in separate places in your program, because you'd probably implement a save and load system with this, or you'd be doing something completely different with it. So there's no real purpose in writing a file and immediately reading it. But for demonstration purposes here, we'll do exactly that. Let's copy this stuff, because the code to read this is going to be really similar. And let's just paste it down here, and we'll change it. I'll format that and then just change this a bit. So let's maybe put some comments in here. Let's say here, write binary file, and then down here we're going to read the binary file again. So now instead of off stream, output stream, we want if stream, input stream, and we'd better call this input file. And wherever I've specified output file now, I could have used my Eclipse's renaming function, refactor function to do this actually. So we change that to input file. This is still okay, iOS binary. We still have to make sure that it's open. And then we're going to do a read instead of write on our ifstream object here. So we still need to close it as well. And here we need to say could not read file. And after we've done all that, then we can actually have a look at the data. So let's take a look at what's in our struct now that we've read it back. In fact, just to really prove that this absolutely definitely works, let's create a new struct here. Let's call it someone else. And if you like, you can initialize it to zeros by putting in here a equals and sort of empty round brackets. So we've got a struct with nothing in it. This is starting to feel a bit like doing a magic trick. But now after we've read into that struct, so let's read into that struct now and output the data. So I'm going to say cout someone else dot name. We'll have some punctuation there, and cout someone else dot age, more punctuation, and we'll output now the height. And let's finish with an endl. Someone pointed out to me since I made this course that I probably should say endl, not endler. Endler is how I always pronounce it. And no one ever contradicted me in my 14 years of being a developer, but endl does, I think it does sound better. So let's run this program now and see what we've got. So now we see that we've successfully read the data that we wrote back into our struct, and we've got the data right here. Okay, that's it for this tutorial. This is really useful when you want to implement saving and opening files in some application. If you want to read some binary format that you didn't create yourself, like let's say a WAV file, then you've got to do a lot of detailed work looking at documentation, if it's available, which it is for WAV, and figuring out what byte exactly means what. And we're going to see that later on in this course. I had to think for a minute which course this is actually for, but this is my Advanced C++ course. And later on, we're going to look at an example of writing to a bitmap file format in a project at the end of this course. Unless I change it, but I don't know why I would. Okay, so until next time, happy coding.